Hi everyone, today our lecture is related to time value of money part 1. In this part, we will be talking about the interest types, present value, future value, then how to compute the present value, future value, what is difference between compounding and discounting. So the key concept which we'll be able to know after going through this lecture. Introduction to valuation, the time value of money. The key concepts are after going through this lecture, students will be able to compute the future value of an investment which is made today. They will be able to calculate the present value to be received in some future dates. Then we will be able to compute the return on investment. Later we will be able to calculate the time periods. There are 4 components: future value, present value, interest rate, and time periods. If value of any 3 is given, then we can calculate the 4th one. As we start from the basic understanding. So the time value of money, what is interest rate, types of interest rates, simple versus compounding rate, future value, and compounding, present value as discounting. This is our concern in this lecture. So here is the basic understanding. Present value, that is called earlier money on the timeline, which normally placed at time 0. Earlier money. So earlier money on the timeline time start from 0 to n. At 0 we normally place the present value. What is future value? Future value is later money. Means the amount an investment is worth after one or more time periods, or we can name it later money on the timeline. And the third part is interest rate, that is rate of change, exchange rate between earlier money and later money. Earlier money means present value, and later money means future value. And what is interest rate? That is a exchange rate, discount rate, or rate of return between earlier and later money. What is interest? The interest rate. Which would you prefer? $5,000 today or $5,000 after 10 years? Absolutely. You wanna have money today. You will prefer $5,000 today. As you probably know that money has a time value. So here is the concept of time value of money. You always prefer today amount, today money, instead of getting the same amount in later dates. So that is time value. That it means the money has a time value. What is time? Why do you think that time is so critical to your decisions? Taking advantage of time permits you to defer your purchases and earn interests. So that is time. Types of interest, as we know that there are 2 types of interests. One is interest accrued only on the original amount, that is principal amount. Interest which is charged only on the principal amount, original amount. And interest paid on any past interest income and principal as well. So the simple interest is only related to the original amount, and the compounding is related to charged on both. What is the both? One is principal amount, original amount, plus interest earned in future dates. So compounding, that is a combination of Here, the combination of interest paid or earned on any past interest income plus the principal amount. Simple interest, which is only charged on the original amount. Compounding, that is charged on principal amount or original amount plus interest earned on the particular investment. So the compounding value will be more as compared to interest. Interest, if there is time period, if the time period is only one, both value will give both, either you choose simple interest or compounding interest, both will give you the same results, same value. If time periods are different, more than one, then the compounding will be more. The value of compounding interest will be more as compared to simple. What is simple? Which is only charge on original amount, and compounding, it's occurred on the original amount plus interest earned on the basic investments. Here we talk about the simple interest formula. What is formula? Simple interest, that is principal amount multiplied by rate of return multiplied by number of time periods. So SI is simple interest. P naught, that is the deposit to date. Why it's not? Today time is 0. Always. Today. It means time is 0. After some time periods. After 1 year, the value of T is 1. And I is interest rate, N is time periods. So simple interest rate, as I have stated, it's only applied on the original money, on the principal money. So here we have an example. Consider a 5 years investment of 5,000 producing a basic interest rate of 7%. After 5 years, how much interest has occurred? So in this case, the basic investment is 5,000 and it's being invested for 5 years at 7%. So in this case, we simply calculate the simple interest amount. Simple interest amount. So the simple interest amount is 5,000, that is the investment today which we are going to invest, present value. And here is the interest rate. Interest rate is 7%. While we put in the formula, we simply convert it into decimal. 7% is 0.07 and time period is given, which is 5 years. So after simplifying, we can calculate the value of simple interest is $1,750. So what is deposit? Deposit's future value. That is the, what is the deposit's future value? That is principal plus simple interest. What is principal amount? Which is 5,000 plus interest, simple interest amount, that's $1,750. The total future value is 6,750. Future value is a potential value of a current amount of money assessed at specific interest rate for a specific time period. So the future value of 5,000 investment after 5 years at 7% is $6,750. So while using the simple interest rate, how we can calculate? Principal amount plus simple interest amount. What is the present value of preceding problem? Here is the present value is just 5,000 you put at the beginning right now, that is the value. The current worth of future sum of money are a series of payments at specific interest rate is referred to the present value. So here is the effects of compounding. What compounding compounding actually deals, the effect of compounding is smaller for a small number of periods, but increases as the number of periods are increases. It means if n is higher, more, the compounding effect is more. If n is smaller, the compounding effect is smaller, or we can name it proportion is smaller. It also depends on the interest rate. The effect of compounding is smaller for a low interest rate, but it increases as the interest rate increases. So it's compounding, and future value is compounding. We can simply say future value increases, we can get the higher future value with a more number of time periods and high interest rate. If number of time periods are smaller and interest rate is low, then the future value is low. There is a direct relationship between future value and interest rate and time period. So future value depends on interest amount and time period, interest rate and time period. If they are high, future value will be more. Okay, that's why we name it compounding. So if we look at here, it deals with number of time periods. If time period is 1, either we use simple or compounding rate, we will be getting same value. In this question, the basic investment is given and the rate of return is 10%. And if we go for the either compounding or simple interest, if time period is 1, both will be same. With the passage of time, the time has increased. If we apply the simple, the overall value will be 120. But at compounding, time has increased. The value at compounding is 121. Then if we go for the third year, the value at simple interest rate will be 130. But compounding, if time is increasing, the proportion of compounding is increasing, the value, future value is also increasing. Okay, so with simple interest rate, it's 130, and if we go for the compounding, that equates 133.10. As I have explained in my first slide, simple interest rate is only applied on the original amount, but compounding is applied on the original plus interest earned on the interest amount. If we look at the fourth year, the simple interest, it can be 140, but while using the compounding, so it's 146.41. What's this? That is the contribution of compounding. So 146 minus 146.41, that is contribution of compounding, and it's the part which is earned on the interest. 6.41 is earned on the interest. So if you look at fifth years, the simple is 150 and the compounding is 161.05. So 11.05, 150, 11.05 is the contribution of compounding which is earned on the interest amount. So here I will repeat my concept, the logic that higher the time period, more will be the effect of compounding. Each year, the proportion of compounding is increasing. That is direct relationship. The curve is rising from left to right upward. That is direct relationship between time period and future value. In this case, the input is time period. Okay, the same I have explained that If the interest rate is high, the compounding will be more, future value will be more. Look at here, interest 0, interest is increasing, future value is increasing. Interest is 10%, future values is also increasing. Look at here, 15%, 20%. There is direct relationship between interest rate and future value. So we can simply say when time or interest rate is increased, then the future value will be more. If they are low, the future value will be less. Another example, the interest rate is 10%. At simple interest rate, compounding 7% and compounding another is 10%. The colors are given. If time period is 1, all will be same. Look at here. After 10th year, the simple rate is less, 7% is less, and interest is, if 10% higher the interest, more will be the compounding, more will be the future value. If after 20th year, the simple is low, 7% and 10%, both are compounding. Obviously, it's understood the 10% compounding amount will be more in future. More the time period, more will be the future value, and higher will be the effect of compounding. Here is it's the simple interest. It's the future value which is calculated on simple interest at 30th year. This is the interest future value on compounding at 7%. Obviously, it's greater than simple but lesser than 10% compounding. So it's validated our understanding that higher the interest rate and time period, more will be the future value and higher will be the effect of compounding. So here we have an example of compounding. Assume that you deposit 2000 at a compound interest rate which is 5% for 2 years. You deposit. It means deposit means we are going to deposit today. That is present value. If you deposit today, 2 days time is 0. After 1 year time is here 1. Okay. After 2 years time is here. 2 is here, 1 is here. The rate of return is 5%. So we will calculate the future value at the end of 2 years. So here will be the future value. 4 components as I have explained. One is future value, second is present value, third is interest rate, fourth is number of time periods. Look at in this question, assume you deposit today, how much amount? 2000 at interest rate 5%. Its present value, its I interest rate, and its number of time period 2 years. Then how much amount we will obtain after 2 years, we will earn after 2 years. Here is the calculation. So future value, this is the present value, 1 plus I raised power 1, and it's the compounding formula. What's this? It's compounding formula, not simple formula. Here for first year, it's for first year at the end of first time period. So P0 multiplied by 1 plus 0.5 raised power 1, answer is 2100. If same amount is calculated for simple interest, do we get the same amount? Yes, because the time period is 1 in this case. Simple and compounding will give you the same value. Okay, so if the number of time periods are increased, then the compounding value will be more as compared to simple interest rate. So what was the basic investment deposit? That was 2000, and here after 1 year we get the 2100. What is 100? That is interest. And we are talking about compounding. Compounding, how much interest here it's earned. Compounding is applied on both principal plus interest amount earned. So it will be applied for next time period, that will be 2000 plus interest on 100. That's why its value is more as compared to simple. Simple is only applied on principal amount, not on both. Over the first year, you receive 1000 in interest on your 2000 deposit. This is same as the amount of interest you would receive with simple because time period is 1. Okay? If you use the simple interest rate, time period is 1. Either you go for compounding or simple interest, you will be getting the same value. Look at here. This is the first year. At the end of first year, by using the future value formula, either we use compounding or simple interest, we will get this value. For 2 years, future value of 2 years, future value of 1 year, that is this, that is $2100. We can put here or multiply by 1 plus I raised power 1, I raised power 1. Why this value? Future value 1 year, that's already been done here. Or you can go for this approach. Present value means investment amount, multiply by 1 plus I, multiply by 1 plus I. Here bases are same, here the power is 1, here the power is 1, bases are same, so we can add. So future value of 2 years, investment is present value means investment amount, 2-day amount, 1 plus I raised power t or n. So in this case n is 2, we can simplify here. So here if we look at here, what is P naught? Basic investment, that is 2000. 1 plus 1.05, 1 plus I means 5%, that's equal to 0.05. If we add in 1, that's equal to 1.05, 1.05 raised power 2. So 2205, that's the answer, 2205. With compounding interest over simple interest, you earned an extra $5. If we go for the simple, here you can get 2200 in 2 years. If the interest rate is 5% and time period is 2, you will be getting $2200, if you use the simple interest rate. And while we are going for the compounding, number of time period is increased, obviously the simple and its value will be different. So we obtained $2205. What is this 5? That is the contribution of compounding on the interest rate, and these $5 are earned on the $100. What is $100? That is interest. That is interest, $100. So with compounding interest over simple interest, you earn on an extra, that is $5 in year 2. So here is the general future value formula. Future value 1 raised power 1, future value 2 raised power 2, future value n raised power n, obviously. So future value, the general formula is future value of n is equal to P naught. What is P naught? That is 2-day amount or investment amount, means present value, 1 plus I raised power n. There are 4 parts in this question. In this equation, there are 4 components. What are those 4 components? Present value, this is present value or P naught. FV, future value. I is rate of return or interest rate, and N is number of time periods. If we know the data of or value of any 3, then we can solve it for the 4th one. Either we can solve the time value questions, we can solve by 3 approaches. First one is by formula. Second one, at this part, is the interest factor. This part is called future value interest factor. Future value interest factor. Or the second approach is we can extract the future value interest factor value from table, interest factor table. So if we look at here, the same question we can calculate the values to whom future value of n number of time periods present value multiply by what is this? This part is future value interest factor. This part future value interest factor of I and n. So P naught, instead of this we can write future value interest factor. So look at table here. What was the basic amount when amount is 1000, future value interest factor 7%, 7% for 2 years. Another example, 7% for 2 years. The basic principal amount is 1000. How we can extract this value? There are rows and columns. There are rows and columns. In columns, here are the number of time periods. Here are the percentages. In this question, what is percentage? 7%. What is time period? 2 years. So how we can extract the exact future value interest factor value figure? So time period is 2 years. We look here. What is the interest rate here? So it's the amount 1.145. That is the amount which can be used as a future value interest factor at 7% for second year. At 7% for second year. I have already explained. Higher the time, larger the time period. Okay, larger the time period, more will be the compounding value or future value interest factor. Higher the interest rate, more will be the value, interest factor value. This part, future value interest factor will be more. I assume if 7% and 4 years, fourth year, the time is increased from 2 to 4th. At second year, the interest factor value was 1.145. If time is increased, obviously it's increased. 1.311. What does it mean? It means we have an argument. Higher the time periods, larger the time period, more will be the interest factor value. Same for interest rate. If interest is increased, time period is 4 years. If we look at here, 1.360, which is bigger than at 7%. Higher the interest rate, more the time period, then greater will be the future value. If time is increased 5 years and interest is 8%, so it's the more bigger value, 1.469. So in previous example, what is time? Here time is second year. There are 2 years. Interest is 7%. So this is the value. We simply extract this value from the table and place here. So we obtained the value, that is 1145. 1145. So the same question, we can calculate from the calculator, time value of money calculator, using the highlighted row. Here is the highlighted row. N means number of time period. I means interest rate. PV present value. FP future value. PMT means it will be used in annuity, more than one payments. Here we are talking about single payment questions. If you have more than one payment, then we can use this payment. In simple questions where we are having the single amount, not more than one amount for investment purpose, then we take the payment value as 0 and as number of time period. So using the highlighted row of keys for solving any of the future value, present value, future value of annuity, present value of annuity. These annuity, we will discuss the annuity series in next class, next lecture. So future value of annuity due, present value of annuity due problems. So our today lecture only deals with future value and present value. We are not talking about payments or annuities. Okay, so if we are not talking about annuity, we'll be having no payments. If payment no payment, then we consider it 0. So n is number of periods. I over y, or y is interest rate per period. PV is present value. PMT, payments per per period. So FV, future value. So how we can calculate? We can clear time value of money calculator clears all the inputs into the above this calculator. Then you can start. So here, look at here. What's this? Concentrate on the third row. Okay, it's third row. N is number of time periods. I is interest rate. PV is present value. PMT, number of payments in per period. And FV is future value. Keep in mind the previous example where interest rate was 5%. Interest rate was 5% and number of years are 2. Present value is 2000. There are nothing payment, that will be 0. Then we can compute the future value. Why we are putting minus here? While we going for time value of money calculator, it will take the present value minus. Why? One is inflow, second one is outflow. When you invest in the market or in any project, it means that is outflow. Present value, that is outflow. The money is going from your pocket. If you receive, when you receive in future some dates, here the answer will be positive. Receive, that is inflow. So keep in mind these concepts will be used in our preceding lectures. So when present value, why we put minus? It's investment. It's going to outflow. And future value, that is positive. Plus value, that is inflow. It means you are getting money. Okay, so here n is 2 years, I is 5. We will not convert into percentage here. PV is 2000, PMT there is no payment, and we can calculate future value. Here is the description. N is 2 time periods into 2. Interest is 5% interest rate per period. Enter as 5, not 0 in decimal. In time value of money calculator, we should be very vigilant while putting the interest rate. While putting the present value, interest will be in digit, not in decimal, and the present value, that is basic investment, which will be in negative. PV 2000, enter as negative as you have less. Less means it's going outflow. It's outflow. PMT not relevant in this situation because we are having only single payment. So enter as 0. Compute means the resulting answer is positive because at the end of 2 years we will receive this money. If we receive, that is inflow. Obviously it will be positive. That was about the future value. The second part is present value. How much do I have to invest today to have some amount in future? How much I have to invest? In this case, how much I have to invest? It means we have to find the today amount. What is today? That is present value. To have some amount in future. Here you are targeting your future price. If you fix a target that I suppose I want to have 10,000 after 5 years at 10% rate of return. So what I have to invest today? What will be my investment? So I have to calculate the present value. It's the basic formula. What is basic formula? Future value is equal to present value, means P naught into 1 plus I raised power n. We can rearrange. Now we have to find the present value. Obviously this part will be dividing here. Future value divided 1 plus I raised power n. We can rearrange here. So present value is equal to future value. Present value if keep this side. This the future value interest factor. This part will be dividing here. So we can write the equation present value is equal to future value divided by 1 plus I raised power n. When we talk about discounting, present value is related to discounting. We mean finding the present value. When we talk about compounding, it means we have to find the future value. Okay. When we talk about the value of something, it means we are talking about the present value, unless we specify, indicate that we want in future. Okay. So there is inverse relation. Discounting, if number of time periods are more, interest rate is high, the present value will be low. Always the present value will be less than the future value. Here is inverse discounting. That's why we name it discounting. Look at this part is denominator 1 plus I. Higher the I, lower will be the overall this ratio. If higher the n, lower will be this value. It means higher the interest rate or number of time periods, more the number of time periods, lower will be the present value. There is inverse relation. In case of future value, there was direct relation between I and n and future value. So in this case, if I either n increase, then the present value will be decreased. Look at here. If interest is 0, so 1 is the value, interest is increased, the present value will be decreased. If interest is more increased, the present value is also more decreased. Higher the interest rate, lower the present value. Same as the case with number of years. If time period is increased, the present value will be decreased. There is inverse relationship. For a given interest rate, the longer the time period, lower will be the present value. And same for a given time period, higher the interest rate, smaller will be the present value. Smaller will be the present value. So in future value, there is direct relationship between interest rate and time period, or we can simply say interest and time period are the directly proportionate with future value. In case of present value, that is discounting. It means there is inverse relationship between interest rate denoted by either R, we can denote it with small r, or we can denote it with small I. Both are same. N can be also denoted by T, time period. Both are same. So in this case, higher the interest rate or time period, lower will be the present value. So here is example. Assume you need 1000 in 2 years. It means after 2 years you are required 1000. What is this? This is future value. Here it's your target amount. You want to have 1000 after 2 years. Time is, its future value is 1000. The value of n is 2. How much you need to deposit today? Today, future or present? Look at the word. That is today. If we talk about today, it means we need to find present value. What is present value? Start from 0. Here it's 0 after 1 year. Here is 1 after 2 years. It's 2 after 2 years. How much money you wanna have? In the question, if you need $1,000 after 2 years, so after 2 years it's one n is 2 at interest rate 7%, and it's yearly interest rate, not quarterly, monthly, and so on. Yearly interest rate, compounded yearly. So future value given, time period given, interest rate given. What's missing? Present value. So we can find the present value, and we know the formula of present value. So it can be calculated. Present value, or P naught, is equal to future value at second year divided by 1 plus I raised power 2. What is I? 0.07. What's n? That's 2. What is future value? That's your target, 1000. So as I have explained, future value is 1000, and always the present value will be less than future value. What is present value here? In this case, the present value is 873.44, and the future value after 2 years at 7% will receive $1,000. So general formula of present value is equal to future value 1 divided by 1 plus I raised power 1 for 2 years, I raised power 1 plus I raised power 2 for n years. It will be future value n divided by number of 1 divided by 1 plus I raised power n. Same can be used formula. We can calculate the same value from present value interest factor table. Present value interest factor table. So here 1 divided by 1 plus I raised power n is the interest factor of present value. Okay, 1 divided by 1 plus I raised power n is the interest factor of present value. Look at here. If present value is 1000, the future value is 1000, interest rate is 7%, number of time periods are 2. So number of time periods, it's second year, here is the 2, and the interest rate is 7%. So this is the present value interest factor. We simply put this value here. So we can calculate the value, 873. As I have explained, that higher the time period or interest rate, if I assume the time period is 5, the interest rate is 8, the present value interest factor will be smaller. If time period is 2 years, interest is 7%, it's 0.873. I assume if the time period is increased by 5 years and interest is increased by 8%. So look at what can be the value. 0.681, 0.681, that's I is increased, time is increased, but the interest factor, present value interest factor is decreased. That's we name it. There is inverse relationship. Okay, so we can solve the same through calculator, time value money calculator. N is 2, interest is 7%. We have to find the present value. There is nothing payments, series of payments. So the future value which is given, that is 1000. So the value is 873.4. Why it's negative? We are going to calculate the present value. That's the calculator takes it the negative. So n is 2 enter 2, I is 7%, enter 7, not 0.7, as we have discussed. PV we have to compute, that is deposit. So resulting answer in negative because it's deposit, it's outflow. PMT, there is nothing, that's not relevant. So we place 0. Future value is given, that is 1000. So you will receive in dollar, that is positive because you will receive after few time period, and it's negative because it's outflow, future values inflow. So here is a question. If you want to know how much to deposit, how much to deposit, money will grow to 10,000. It means future value in 5 years. After 5 years, you will receive 10,000. In this case, 5 years at 10%. I is given, T is given, means N is given, future value given, how much you deposit today. Okay, so present value we have to find. Number of time periods are 5, interest rate is 10%, and the future value is 10,000. We can solve it. So calculation based on the general formula. So here is the present value is equal to future value divided by 1 plus I raised power n. So we can simply put these values, the data, into given formula. So what is given formula? Present value is equal to future value divided by 1 plus I raised power n. In this case, future value is 10,000 divided by 1 plus 0.10 raised power 5. So the overall calculated value is $6,209.21. The calculation. So the future value, our target is 10,000. The future value is 6,200. As we know that the present value is always less than future value. The same we can solve by table, interest factor table, present value interest factor, interest rate, that is 10%, time period is 5. We can extract present value interest factor from the table. So its value is 0.621. So we can get the same answer. So 6,210. How much is the difference? There is nominal difference. And what's the effect of this difference? That is due to rounding. Same we can calculate from the time value of money calculator. N is 5 years, interest is 10%, there is nothing payment, and future value is given, which is 10,000. The overall calculated amount is $6,209.21. Okay. So here is another concept. What is this concept? Rule of 72. When it applies, rule of 72 is applied once n is missing. If n is missing, number of time periods are missing, and the other characteristic is, other basic assumption is, the future value is double of present value. The future value is double of present value, and n is missing. Then we can go for the rule of 72. Here is a quick question. How long would it take? How long would it take? It means we have to find the n. To double of 5,000 at annual compounding rate. Double of 5,000. If you invest 5,000 today, it means present value is 500. What's its double? That will be 10,000. Interest rate is 12% approximately. How much time it will take to get it double at 12%? It means the future value is double of present value. Then we can go for the rule 72. We will use the rule of 72. And rule of 72, how we can calculate? Simply 72 divided by interest rate. 72 divided by interest rate. Then you can find the number of time periods, approximate number of time periods. Look at here. 72 divided by I. What is interest rate? That is 12. Don't convert it into decimal. So 72 divided by 12. So its answer is 6 years. 6 years. It's round. Approximately. If we calculate it through formula, so actual or calculated time will be 6.12 years. They are more or less same. There is nominal difference. So we can calculate from the calculator, time value of money calculator. We have to find the n. Interest is 12%. Here we are going for actual calculation. previous, for example, 1000, future value should be double of present value, should be double of present value. Okay, then interest is given. If we there is nothing payment out of 4 components, we have the data of 3, then we can calculate 6.12 years. The outcome indicates that $1,000 investment earning at 12% per year would double, that is would be double, which is 2000 in 6.12 years. Note, rule of 72, the approximate 6 years. Here the overall calculation is 6.12 years. So we can use the rule of double 2 when the future value is double of present value, and we have to find the number of time periods. Then we can apply the rule of 72. So this was all about today lecture, and our next lecture will be dealing